Hey, physicists. So you just finished the question about the force that a crash test dummy would experience if they were traveling in a car, traveling at 40 miles per hour, hitting a barrier, and came to rest. So I put that math up at the top there so you can take a peek. Looks like the force that they would experience was about 4,000 newtons, which would result in an acceleration of about 68.8 meters per second squared, which sounds like a lot, but on the whole, is a survivable type of situation. We're going to take a look real quick at what would happen if that crash test dummy was traveling same scenario except without a seatbelt. Okay, so kind of the same deal that's going on. We're just going to run through this quick in terms of what might happen. So think about if you're not wearing a seatbelt, when that car hits the barrier, there's nothing to stop you. So the driver is going to go ahead and continue on forward because there's no force that's going to stop them. We're going to kind of plug some numbers in here to see what that's going to look like. So just after impact, okay, the driver will probably travel for about 0.1 seconds, okay, with no force. Okay, in that 0.1 seconds, we can figure out how far the driver would move. Okay, so the driver and the car are all moving. We're going to say that the distance that the driver will move, this is all just kinematics from stuff that you did in Unit 1, okay, my favorite equation. We're going to get rid of the acceleration because we said there's no force. That means no acceleration. The distance that the driver or the crash test dummy would move is, well, it's going to be 17.9 meters per second times 0.1 seconds. That gives us 1.79 meters, okay? So the crash test dummy is going to move 1.79 meters. In that same 0.1 seconds, the car is going to continue to move as well, but the car is moving with some acceleration, right? We found that acceleration is actually negative. I guess, I don't know, I didn't put my negative sign in there because it's slowing down. So in that same 0.1 seconds, okay, the car will slow down, and we can figure out how far it's going to travel. Delta x, same equation, VIT plus 1/2 AT squared, same initial velocity. It's all moving together, 17.9 meters per second times that 0.1 seconds, okay? Plus, now we are going to do some acceleration. It's a negative acceleration because we're slowing down, so that's going to be 68.8 meters per second squared times that 0.1 seconds squared. When we plug in those numbers, you can find that the car actually is only going to travel 1.45 seconds, or meters, excuse me. So the crash test dummy travels 1.79 meters, while the car only travels 1.45 meters. Thinking about that, that really means that the crash test dummy, you've seen this in videos before, right, is going to travel forward, and at that point will have traveled 0.35 meters or 35 centimeters further, moving it into and impacting the steering wheel. Okay, so at that point, now everything's squished together. Now everything's going to move at the same speed. So this difference, this 1.79 meters minus the 1.45 meters, says that the crash test dummy travels 0.35 meters relative to the car, and that means that it collides with the steering wheel. Okay, that whole thing, the car, the steering wheel, the crash test dummy are all going to keep moving, and we're going to look just a fraction of a second later at what is going to happen. Okay, so if we think about the car and the steering wheel and the crash test dummy all traveling together, let's say just for another 0.02 seconds. So just a very little snapshot in time, okay? We can figure out the final velocity at that point. Another kinematics equation, VF is equal to VI plus AT. We know that the acceleration, it's that same acceleration because the car just keeps slowing down, not really impacted by the fact that the crash test dummy has impacted the steering wheel. So we've got an initial velocity of 17.9 meters per second, okay? Oops, and then we're going to add, or actually in actuality subtract, it's going to be 68.8 meters per second squared times the total time is going to be 0.12 seconds. So that we're looking at the very beginning, right before the crash, and right after the impact, and then this last little snapshot moment. So after a total of 0.12 seconds, then we know that the car and the steering wheel and the crash test dummy all are moving at a speed of 9.6 meters per second. Okay, this is the value that I wanted to share with you so that you can solve the problem. So let me kind of sum up the problem that you are being asked to solve. You've got a crash test dummy with a mass of 60 kilograms, had an initial velocity of 17.9 meters per second, okay, and just 0.2 seconds later, or 0.02 seconds later, okay, has a velocity of 9.6 meters per second, because it doesn't slow down until it hits the steering wheel. So that's why the 0.02 seconds is there. So you've got the mass, the initial velocity, final velocity, and time. And I would like you to use those things and the impulse momentum theorem to figure out what the force will be on the crash test dummy. Take a look at that relative to the answer right before. Thanks, guys.